Hi there everybody, Dr. Emilio Kardaris here, and I'm here today to talk to you about light and sleep. Now, you're probably wondering what light and sleep have to do with one another. The key is to look at the eye. Your eyes are going to be your biggest organ, I guess, that will help dictate what happens inside your body clock. Now, body clock in scientific terms is called the circadian rhythm, and that rhythm is what keeps you awake and helps you go to sleep, and then is your sleep-wake cycle when you're actually asleep. Now, in order to understand exactly how your eyes, how light, and how those two together affect sleep, it's important to know how the eye works. So let's take a look at the eye. Now, as you can see on the image in front of you, the eye is broken up into a number of different chambers, if you will. Light passes in through the front of the eye, through the lens, and comes in through into your eye and passes onto the back in the retina. But that information, once it hits the back of the retina, gets passed through the optic nerve and passes into the brain where it is processed, and then we have vision. So, as we can see with our eyes and that information is processed, light of different colors is also processed slightly differently. Let's take a look. So in order to understand exactly what kind of light passes in through our eyes, we need to have a bit of an understanding of basic physics. Light is a beam, so it's going to be acting kind of like a wave. Now, we've got high intensity or high energy waves, and then we have low energy waves. If we have a look at this picture here, we can see that as our increase in our wave length goes along, so as the waves get further apart, we can see that the energy actually goes down. And as our wavelength decreases, or is more fast, we can see that energy passed through is quite higher. Now, what I want to draw your attention to is at the very bottom of this image, we can see a spectrum of light colors. We can see where violet is, and we can see where red is on the opposite end of the spectrum. Now, violet is going to be your highest wavelength light. It also has the most energy in it too. We can see it's actually quite close to UV light and X-rays as well. Going further down to the other side, we have red light, which is closer to infrared. And we can't actually see infrared light. It doesn't get processed by our eyes very well, but we can see the color red. So the color red has a much longer wavelength than the color blue or the color purple. And what I want to draw your attention to is blue light, because that is something that we're exposed quite a bit to these days. How does blue light affect us? Well, in the good old days, we basically used the sun to give us our light. So during the day we were awake and the sun was up, and then at night things were relatively dark. I mean, yes, we had candles, but it wasn't the same as what it is today. Blue light is emitted from our electronic devices and also from smart saver or energy efficient light bulbs. And what that blue light does is it actually passes into our eye as quite high energy, and it's very close to the same amount of energy that you get from sunlight. So you can imagine as you're winding down at the end of the day and things are getting darker around you, including your environment, staring at a computer screen or using our lighting for long periods of time is actually going to be tricking our brains into thinking that it's still daylight. And this can severely affect our circadian rhythm. If we look into it, Harvard actually did a study on this, and they tested the difference between exposing people to blue light and exposing people to green light for a long period of time, and then seeing how that affected their sleep patterns. What they found is that blue light affected the sleep patterns of people twice as much as what green light did. And if you remember that little graph or that little picture, green has actually a lower energy profile than blue. So how can we help prevent ourselves from exposing too much blue light? Simple. Stop using your iPhone, your iPad, or your computer before you go to bed. Usually around about 1 or 2 hours before you go to bed is enough to help you get your body back into that rhythm so that you can actually start sleeping better. We'll talk about the physiology of sleep in another video, but basically what I want you to take home is light does affect what happens when you sleep, and blue light is not going to be very beneficial for us. So switch off those computers, shut down those iPhones, and let yourself prepare for sleep naturally. Until next time, trust your instincts. This is Dr. Emilio Kardaris.